3.5, rational functions, graphs, applications, and models. Alright, so some of this section we're skipping just because don't need to worry about it as much. So the first thing says to give the equations of any vertical, horizontal, or oblique, or sometimes we also call them slant asymptotes, for the graph of each rational function. So 38, f of x is equal to -6 over x plus 9. So just as a refresher for vertical asymptotes, we set the denominator equal to 0 and solve. And anywhere that the denominator is 0, that would make it undefined. There's a vertical asymptote. Horizontal asymptotes, we have 3 scenarios for that. We have Bobo, Bosco, and Botno. Bobo is bigger on bottom, y equals 0. Botno is bigger on top. There's no horizontal asymptote. And if they're both the same, then we use the coefficient that's in front. And that's talking about the highest powered term when we say that. And all that should be written in your notes so you have it. Oblique and slant asymptotes, this is the one that probably gets used the least because a lot of times we just kind of like disregard them. But it's good to know like what they are. So if the numerator is 1 degree higher, so like x squared over x, so 1 more than the denominator, there's a slant asymptote, and we would divide the numerator by the denominator by synthetic division. Or, well, depending on the situation, we could have to use long division, but we won't do the long division ones. And then we would get an equation. So, on this first one, I'm looking for any asymptotes. So, I'm going to look for vertical first. And so we're going to set the denominator equal to 0, so x plus 9 equals 0. So that means that x is equal to -9. So that means that I have a vertical asymptote at x equals -9. And asymptotes are always written as an equation of a line. So if you don't have the x equals, or when we get to horizontal y equals, then it won't be completely correct. All right, horizontal asymptotes, we need to look at the degree of the highest powered term. So on top, there's no x term, so it's just like a 0. On the bottom, we have just an x term, which would be to the first power. So it's bigger on bottom. So bigger on bottom is Bobo, which means that y equals 0. So the horizontal asymptote is at y equals 0 because of Bobo. See, 40 f of x is equal to 2x plus 6 divided by x minus 4. So vertical, set the denominator equal to 0, so x minus 4 equals 0. So that means x equals 4. So I have a vertical asymptote at x equals 4. Then I'm looking at the highest powered term, so I have 2x over x. So those are both just x's to the first power. So those are the same. So if they're both the same, we use the coefficient in front of them. So that would be 2 over 1 or just 2. So the horizontal asymptote is at y equals 2 for this one. Bosco. Let's see, 42. F of x is equal to x squared plus 4 divided by x plus 1. So how would I find the vertical asymptote for this one?
X 1. So the x is equal to -1.
Yep. So the denominator equal to 0 and solve. So vertical asymptote at x equals -1. Horizontal asymptote, looking at the highest powered term. So I've got an x squared over an x. That's bigger on top. So that's bot no. Bigger on top. No, there's not. So just so that I know you didn't just disregard it, just write none or no or something like that for horizontal asymptote. Now, when there's not a horizontal asymptote, that's when we have to check for a slant asymptote, okay? If the degree is only one difference, like it is in this one, then we're going to do synthetic division and check for a slant asymptote. So we're going to use this number on the bottom. Did I copy the problem wrong? I copied the problem wrong, but it doesn't matter. It's not going to change anything. So to check for a slant asymptote, we are going to take the opposite of this, just like we did when we were doing synthetic before. So we're going to put a -1 in the box, and then we're going to put the numbers from up here, and it's still, if same policy, if a number is missing or a term is missing, we got to put in a 0. So I've got 1, 0, because x is missing, and then 4. So bring down the 1 times -1 is -1, plus 0 is -1, times -1 is 1, so then that's 5. So then what's left down here, we ignore the remainder. We don't care about that for slant asymptote. This was an x squared term, so this is now an x term, so this is going to be x minus 1. And all we do is write y equals that, and that's how we get our slant asymptote. So it's going to be y equals x minus 1. Now, do you notice anything about the equation of a slant asymptote compared to a vertical asymptote or a horizontal asymptote?
It's y.
So is horizontal. What's different about...
y and x.
Yeah, so it's an equation of, like, I'm going to say a normal line. Obviously, x equals and y equals, they're lines also, but they're horizontal or vertical lines.
And that's like
obviously.
y.
Yeah, so that would be when, like, it's going to graph literally a slant. Okay, so we would have, like, at -1, we would have a point and then a slope of 1, and going, up 1 over 1. Now, you're not actually graphing these right now, but we could, based on this information, use that and be able to graph it. Let's see, 44. F of x is equal to 3x squared minus 6x minus 24 divided by 5x squared minus 26x plus 5. What's happening? There. Okay. So, with this one, obviously this looks a little different than the last several that we've done, right? So, I need to still do the same process, but now I'm going to need to factor the bottom, okay? Because I need to find, in all the ones that we've had so far, there's only been one vertical asymptote. Okay, there could be more than that. This one in particular is going to have more. So I'm going to take this 5x squared minus 26x plus 5, and I'm going to factor it. And then once I factor it, I'll set it equal to 0 at that point. So, do we remember how to arch method factor this?
Okay, so it'll be 25, 5 times 5. And then you have to find what times 25 would be negative 26. So that'd be negative 125.
Yep.
Or negative 25 and negative 1.
Yeah, it doesn't, yeah. Order doesn't matter. So we're going to replace this negative 26x with negative 1x and negative 25x. So 5x squared minus x minus 25x plus 5. Factor by grouping. So I'm going to take out an x. So I'm left with 5x minus 1. Over here, because I need the negative to end up over here, because of how this ended up, I'm going to take out a negative 5. So negative 5, and that leaves me with 5x minus 1. So again, just a reminder, the parentheses have to match when I'm done. And so I get x minus 5 and 5x minus 1 are my two factors. At this point, that's when we're setting it equal to 0 to find our vertical asymptote. So I'm going to split them up individually. So x minus 5 equals 0. 5x minus 1 equals 0. And then I'm just going to solve for x. So that's going to give me x equals 5. And x equals, move the 1 over, divide by 5, so 1/5. So vertical asymptotes now, so I have 2, so I'm just going to write them as x equals 5, comma, x equals 1 over 5, and that's just the way to write both of them. Now, I've got more terms here, so I need to also look at horizontal asymptote. Which terms am I paying attention to for horizontal?
Y.
Well, it's going to be y equals, but in the original, to find the horizontal asymptote, what am I looking for?
Top one. Top. Top one.
Sort of.
Ah.
Which one is that?
Negative 24.
So 3x squared on the top. What about the bottom?
5x squared.
Yep. So I care about the highest powered x terms. Okay, they won't always be written on top of each other. Sometimes they could have them out of order, and so you have to find which one is the highest powered one if it's not like written in order. So I have an x squared term and an x squared term. So what is that? Which situation? Is it Bobo, Botno, or Bosco?
Bosco.
Bosco. Both the same, so we use what? Or what is the horizontal asymptote?
X squared.
Nope.
0.
It's a number.
1.
If they're both the same, we use the coefficient. So what would the coefficient of this be?
Oh. Yeah, what would that be? Distance is what?
Of which one?
Of what's encircled.
3 over 5.
Yes.
3/5. The correct term.
All right, horizontal asymptote is at y equals 3/5 because of Bosco.
We're gonna have some slant asymptote.
So we only have a slant if there's no horizontal.
Oh, okay. I'm making sure, Tristan. That wasn't smart of you.
There's only one problem in the homework that I see that will have a slant. All right, one more. I want you to try this one on your own. It's not a hard one, promise. So try this one, and then we'll go over it, and then we're done with this section. I'll give you some problems. 46. F of x equals 4x squared plus 25 divided by x squared plus 9. Actually, pause. I need to show you the vertical asymptote for this one. I didn't realize what it was. All right, the vertical asymptote for this one is going to be a little weird, okay? So we still set the denominator equal to 0. So we move this over, so I've got x squared equals -9. So then I take the square root. So x is going to be equal to plus or minus the square root of -9. But what's the problem here?
Oh, we don't know if it's positive or negative.
Well, no, it would be positive or negative, but there's something else that would cause a problem here.
The
The negative?
The negative inside the radical, right? Is there any way that we can do that with real numbers? No. So for vertical asymptote, there's going to be none.
Oh. Interesting.
But now y'all can find the horizontal asymptote.
Bosco, what's up? Wanda.
Bobo, Bosco, Botno.
Botno. Bigger. Okay. Bot.
All right, what do we get for horizontal?
What was it before?
Y is equal to 4. Does everyone agree? Anyone disagree? Cool. Yep. Y equals 4.
Whoa, how'd you do that?
Magic.
Did you write in invisible ink?
There's a freeze button on my screen.
That's cool. That's the coolest thing I've seen today.
Probably haven't seen a whole lot today at this point, I'm guessing. All right, so your problems are 37 through 45 odd. Okay, only one of them is going to have a slant.
I just need some.
Yeah, one has a slant.
Okay.
375. So make sure you have 3.6 notes if you haven't done them for Monday. Pretty sure there were notes for that section. Because we'll be moving on to that section. Probably we'll just do a quiz on 3.4 to 3.6. Depending on how long 3.6 takes us, it might be Wednesday, but it might not be till like next Friday. Because
Hopefully we don't have school next week.
Huh?
Hopefully we don't have school next week.
Next week?
Hopefully we get snowed out.